Okay, let's look at the next question. So very similar actually to the previous one. So a circuit was set up using a 12-volt battery as shown below. The switch is closed. What will be the reading on the ammeter? Once again, don't do 12 volts and 4 ohms. The 12 volts is the total voltage. So the first thing we have to do here is work out the total resistance, which is 4 plus 4, which is 8 ohms. We can then do V equals IR, where we use the whole voltage and the whole resistance, and then 12 divided by 8 equals I, which gives us 1.5 amps. When the switch is closed, what will be the reading on the voltmeter? Two ways you could do this. We could do V equals IR. V, the voltmeter is across the 4 ohm resistor. So 1.5 times 4, and it is 6 volts. The other way of looking at this is, well, that's a series circuit, and there's a 4 ohm and a 4 ohm resistor. They're identical. Going this loop around the circuit, the voltages have to add up to give 12. So therefore, half of the voltage will go here, and half of the voltage will go here. Okay, next one. Circuit is altered by connecting a 2 ohm resistor as shown below. Calculate the total resistance of this altered circuit. So I'm going to start out by adding these in parallel. Remember, we use our reciprocal equation there. So 1 over RT is 1 over 4 plus 1 over 2, which is 3 over 4. Flip it upside down, and it gives us that is 4 over 3, so 1.333 ohms. Add on the resistor that is in series, so that is our previous 4 one. Add on the 1.333, and that gives us 5.333 ohms. Okay, or 5 1/3 ohms. Calculate the new reading on the voltmeter. Now, it's no longer going to divide 6 and 6 because of that addition of that 2 ohm resistor in parallel. So we need to go through the same steps we went through before, where we first work out the total current in the circuit. So dealing with the whole circuit, 12 volts is the whole voltage. The whole resistance is 5.333. 12 divided by 5.333 is equal to I, which is 2.25 amps. Now that's the total current, which if we look at this circuit, will pass through this ammeter, so it will read 2.25 amps, and all of that current will pass through this resistor. Now, by the time it gets here, it then has a choice what way it goes. There's a junction there, but we know that all that current flows through that resistor. So just looking at this part of the circuit now, okay, that 4 ohm resistor, we can use V equals IR on that portion. And V equals 2.25 times the resistance, which is 4. So we get that is 9 volts. Okay.